In this lesson, we're going to go over area of squares and rectangles and complex polygons. So if you're taking the notes on a separate sheet of paper, if you could just label it as area of squares, rectangles, and complex polygons, just so that you have it labeled correctly. Label it areas of squares, rectangles, and complex polygons. So you can go ahead and read the content and language objectives. What we're trying in this lesson, what we're going to learn is how to find the area of squares, rectangles, and complex polygons using the correct formulas. And our language objective is to be able to explain how to find the area of the shapes using the sentence stem. The shape is a blank, the base is blank, and the height is blank. Okay. So let's go ahead and start. So the warm-up lists 3 things that you know about rectangles and squares. So if you want to take a minute and pause the video and go ahead and write 3 things that you know about rectangles and squares. Okay, so a couple things that I want to point out is about rectangles and squares before we define area is that both rectangles and squares, they both have 4 sides. So this is an important fact. Both of these have 4 sides. Another important fact about rectangles and squares, they both have 4 right angles. And lastly, in rectangles and squares, opposite sides are parallel. And actually, if you want a 4th fact, in squares, all 4 sides are the same. Okay, so those are some facts that I thought of that would be important for us as we go through this lesson. So take a minute, compare your facts, what you have written down, see if yours match mine. And I'm going to clear this just so I have more room to write. Okay. So what is area? Area just tells you how much space an object or a figure or something, how much space something takes up. So how much space. So on your notebook paper, I would say area. And then I would give the definition, how much space an object takes up. Or you could say covers, so how much space an object covers. So like, how much space does your rug in your living room cover? How much space does space does your grass cover? So all of those things would be represented with area. So in this first example here, you have 2 figures, figure A and figure B, and they want you to find the areas of each of those figures. So for figure A, one way to find the area is just to count up each of the little blue squares inside that rectangle. So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the area of A, so the area here is 18, and we don't know the units. Like, we don't know if these are represented by feet. We don't know if this grid is talking about centimeters. So since we don't know the units, we're just going to say it's 18 units squared. Very important, this squared part. If you don't include the units squared, you would lose points there because area is always represented by square units. So you need to include units squared. And then figure B, and you guys probably know a shortcut to finding the areas because you guys studied these in other math classes most likely. But if we just counted up all those squares inside that red figure, how many are there? So go ahead and take a second, count up those squares. How many are there? So if you counted them up, you should get that there are 20 squares, and we don't know what these units are. We don't know if this is measured by feet, centimeters, or whatnot. So we're just going to say 20, and we'll say units squared. Again, notice that I put the square with my units. So make sure you do that as well. Okay. So finding the area. To find area of a square, there's a number of ways that you can find the area of a square. So the one key thing with squares is that all the sides are the same. So if you have this is a square, then if this is my square, then all the side lengths are the same. So you'd see these tick marks. These tick marks mean that these side lengths have the same measure. So there's two different formulas that we can use for area of a square. One of them is area equals whatever the side length is squared. So for example, if this was 6, then the area of this would be 6 squared, which is 36. And then whatever the units are, unit squared. So this is one formula. Another formula is this. So for squares, area is base times height. And your base and your height are going to be the same since all the sides are the same. So if this is 6, then this side is 6. So your base is 6 and your height is also 6. So either way, you get 6 times 6, which is 36. So there's two ways that you can do area for the squares. For rectangles, there's only one formula. It's area equals base times height. So let's look at an example. So here's number 1. So there might be some markings in this figure that you're not familiar with. For example, this marking right here. This marking means that this is a 90-degree angle. So when I said earlier that there are 4 right angles, the 4 right angles are denoted by these little squares in the corner. It means that this measures 90 degrees. So I don't have like a protractor in front of me to measure these, but I know based on the labeling of the figure, these are 90 degrees. Additionally, as I talked about just a moment ago, when I talked about areas of squares, these tick marks mean that all these sides are the same. So if this is 11, then this is 11, and this is in meters. So if I want to find the area of the shape, I know that this is a square. So to find the area of the square, I'm going to use this formula, this area of a square. So area, so we'll say A equals base times height. So we'll say B times H. Well, so what's the base? So in this picture, in this first figure, the base is this one, so it's 11. And the height is always perpendicular to the base, so it always forms a right angle with the base. So here's my right angle right here. So this is my height. So my base is 11 and the height is 11. So this is 11 times 11, which is 121. And then don't forget we need units squared. So 121 meters squared. Now, just so that you know, it doesn't matter which height we chose. We could have said, let me erase this real quick. We could have chosen this height, and either way, notice this side is also perpendicular to the base. It also forms a 90-degree angle. So, and it's also 11 because this is a square, right? So it doesn't matter which height we chose, this one or this one, they're both perpendicular to the base. Number 2, what shape is that? Is that a square or a rectangle? So if you said rectangle, you're right. And the reason why it's a rectangle is because my side lengths are not all the same. So this is a 2 and this is a 6. So notice those aren't the same. So this is a rectangle. So to find the area of the rectangle, we're going to say area equals base, so B, times H. So B stands for base, H stands for height. So the base is here is 6. So the area is 6 times, and then the height, remember the height is always perpendicular to the base. So we're looking for this little right angle symbol. So the height here is 2. So 6 times 2. So that is 12. And our units here are feet. So this is 12 feet squared. So this is your area for that one. Number 3, what shape is that? So I want you to try that one on your own. Pause the video and then do number 3. Okay, so for number 3, you should have gotten the area is base times height. This is a rectangle. The base here is 5.9. And then the height, remember the height's always perpendicular to the base. So here's my perpendicular symbol. And then here's my height is 4.5. I have it written backwards here, but that's okay. Remember, in multiplication order doesn't matter. So, I said 4.5 times 5.9. All right, next example. So it says a rectangle has an area of 52 square meters and a height of 4 meters. Find the length of its base. So let's go ahead and sketch out what we know. So I know that, let me erase some of the stuff that we don't need. So let me erase this and this. Okay, so so it says a rectangle has an area of 52 square meters and a height of 4 meters. Find the length of its base. So I know that my shape here is a rectangle because they tell me it's a rectangle. So I'm just going to sketch a rectangle on my paper. I know that the area of the rectangle is 52 square meters. So I'm going to say area is 52 meters squared. So I know the area. It has a height of 4 meters. So I took care of the area part, and a height of 4. So remember, the height is always perpendicular to the base. So if this is my base, I'm going to call it B. Then this is my height. So because it's got to be perpendicular to the base. And again, doesn't matter. You could have chosen this side for your H, because in rectangles, opposite sides are parallel, so, or congruent. So these two sides have the same length, and these two sides have the same length. So the difference here, this one tick mark means this and this are both H. And then the double tick marks mean that these are not necessarily this, B is not necessarily the same size as H. So the double tick marks just say, hey, this is a different measurement than the single tick mark. We know the height. What is the height? Good. The height is 4 meters. So what we don't know about this picture then is we don't know what B is. So if we write down our formula, area equals base times height, we could fill in, well, we know what the area is. It's 52 meters squared. So we can write 52. We don't know what B is, and we do know what H is. It's 4. okay? So if I want to find what B is, then I just have to solve this equation for B. So how do I get B by itself? So I'm doing B times 4. What undoes multiplication? So the operation that undoes multiplication, good, is division. So these 4s would cancel. And 52 divided by 4 is 13. So 13 meters is the base. So you do need to include units in your answer. So the base is 13 meters. It's not meters squared because then that would be talking about an area, which we already had the area. We knew that the area was 52 meters squared. So if we're talking about just a side length, it's just straight meters. There's no meters squared in a side length. So my B, I can come over here and write, is 13 meters. And you can always double check your work. If you go back and say, well, is 13 times 4 equal to 52? And the answer there is yes. Okay, you guys are doing great. The next example. The next example is finding the area of a complex polygon. So this figure here has, notice it has there's 3 shapes that make up this weird looking figure. If I want to find the area of this whole figure, I need to find the area of each of these individual pieces. So I need to find the area of F, G, and H. And that will tell me the area of my polygon. So notice this polygon is made up of rectangles. So let's start with the easier two. Let's start with finding the area of F. So F, so let's say area of F. To find the area of F, area equals base times height since it's a rectangle. So what is the base? So this is the base, it's 4, then what's the height? Good, the height should be 3. This is the height. So 4 times 3 is 12. So this is 12 centimeters squared. Yes, you need to include units squared. Oops. So this is the area of figure F. Okay, now let's do, the area of that red piece looks like it's going to be hard. Let's do the area of the green piece. So area of H. Oops, I spelled that wrong. So area of H. So area of the green piece. So remember, these are all squares and rectangles. So area equals the base, which is 5, times the height. So 5 times 2. So 5 times 2 is 10, and this will be centimeters squared. Now the area of that red piece, the sort of the harder of the two. This one you kind of need to think a little bit to do it. So for G, I want to know, I need to know the base and the height. So notice I know that this whole thing here is 9 centimeters. And how do I know that this whole thing, this whole length here is 9 centimeters? Because they tell me it's 9 centimeters right there. But I also know that this green portion from box H right here, I know that this is how long. How long is that? So remember, opposite sides in rectangles have the same length. So what side is on the opposite side of this? So if you look directly across, it's the 2 centimeters. So I know that this length is 2 centimeters here. Okay, and this whole length is 9. So if I want to find this length from here to here, how might I do that? So if you said to subtract 2 from 9, you're right. So 9 minus 2, this length here is 7 centimeters. So from here to here in this red rectangle is 7 centimeters. So we can call this our base, and that's fine. Let's call this the base. We'll call this B. Now we would then need to find the height. Remember, the base is always perpendicular to the height. So I'm going to draw a right angle in here. So here's my right angle. And this is my height. My height is only this length here. So to find this length, I'm going to also need to use a little bit of logic, just like I used to find that this was 7. So this whole length from here to here is 7 centimeters. But I know that this length here is 4 centimeters because this is 4. So if this is 4, then that has to be 4. So that means if I want to find this length, I'm going to do 7 minus 4, which is 3 centimeters. So this is my H for that one. So to find the area of G, let's go down a little bit. I'm going to do area equals. Now my base we said was 7, so base times height. So area is 7 times 3, which is 21. This is centimeters squared. So that's the area of G. Now I'm not quite done because I found the area of each individual piece. Now I need to find the area of all of them. So if I want to find the area of the whole figure, I just have to add all the areas up. So my total area I'm just going to add each of the areas. So I'm going to say is area of G plus area. Sorry, I spelled that wrong then. Plus area of H plus area of, what was the last one? F. So I'm going to add all those up. So this is going to be 21 plus 10 plus 12. So if you add all those up, you get 30, you get 43, and then you must include centimeters squared. So your area there is 43 centimeters squared. Okay. These next two problems are for you to try. They're complex polygons, and each of them are complex polygons. So you're going to need to find the area of each individual shape and then combine the areas. So here you should be finding 2 areas. And so for the number 5, you should find 2 areas and then add those results together. So you're going to find the area of this shape, and then you'll find the area of this shape and then add them together. For 6, you're going to find the area of this shape, the area of this shape, and then the area of this shape, and then add them together. We'll go over the answers to 5 and 6 before you leave. If you didn't make it to class, pause the video, give 5 and 6 a try, and then I'll put the answer. After you've tried it, click play, and then you'll be able to see the answers for those 2. So here is the solution to 5 and 6. So in 5, the area of this rectangle is given here, right here. And then in 6, this is a square, and the area is given here. So this is 5 and 6. There was 3 pieces. So the first area of the area of this rectangle is given up here. The area of this square is this square right here, this 3 by 2 is given down here. And the area of the yellow rectangle, sorry, that was a rectangle too. The area of that rectangle, the yellow rectangle is given right there. So the total areas for both, so for 5, it's 30 inches squared, and for 6 is 54 meters squared.